Today, high-performance structures are essential in order to meet a variety of demands, from economic to environmental. The United States federal government defines a high-performance structure as one that integrates and optimizes on a life cycle basis all major high-performance attributes. At the heart of this definition are two essential concepts. The first is using materials and systems that integrate and optimize all high-performance attributes. The second is a paradigm shift in perspective from solely first cost to a life cycle basis. While there are many high-performance attributes, these can be summarized into three basic groups: versatile, efficient, and resilient. In order to build high-performance structures, we need to use high-performance materials and systems. Precast concrete is a high-performance material that integrates easily with other systems and inherently provides the versatility, efficiency, and resiliency needed to meet the multi-hazard requirements and long-term demands of high-performance structures. Precast concrete is being used more and more to help these projects meet and exceed their high-performance goals during design, construction, and operation. Let's discover high-performance precast. Precast concrete is versatile, which is essential in design and construction. Precast concrete has excellent aesthetic versatility because it can be manufactured in almost an endless array of colors and textures. These are achieved by using a variety of aggregates, finishing techniques, and sometimes colored pigments. Precast concrete can also be embedded or veneered with many natural materials, such as clay thin brick and natural stone. This provides all of the natural beauty of these materials while adding all of the high-performance benefits of precast concrete. Precast concrete allows the designer to create a variety of shapes, patterns, and details that are often more difficult, if not impossible, to achieve with other materials. Multiple finishes can be combined into one panel, which reduces detailing, joints, flashing, and maintenance costs, as well as the associated risks that often exist when interfacing different materials. Precast concrete is also a structural material, which means it can be used as a structural and cladding system simultaneously, minimizing material usage and accelerating construction. In today's financial environment, reduction in the overall construction schedule results in quicker return on investment, making precast the optimal solution. Since precast concrete is essentially custom designed and manufactured for projects, it allows for design flexibility needed to overcome unique situations, ultimately allowing for easier project optimization. Precast pre-stressed concrete also provides for longer open spans with less columns and obstructions. This allows floor plans to be more easily adapted as a building's functional use changes throughout its service life. Its versatility also allows for scalable performance. New energy codes require different thicknesses of insulation depending on a project's location. Precast is easily scalable to meet these requirements. High-performance materials and systems must be efficient, both in construction and in use, by helping reduce a structure's overall life cycle costs. Precast concrete is manufactured off-site in a controlled environment. This helps minimize negative impact to a construction site while maximizing quality. Precast concrete does not require on-site storage or staging and is delivered to the project as it is needed. It is typically erected with a crane and a relatively small crew, which allows for construction within a tight perimeter of the project. This can greatly decrease the footprint requirements of a project site and help minimize disruption to the surrounding areas. Precast concrete arrives to the project ready for installation and is one of the fastest building systems available. This helps reduce the construction schedule and enclose a structure quickly. Precast concrete helps reduce a project's overall life cycle costs, including energy usage. Because it is made of concrete, precast has thermal mass, which can be used to reduce the total energy needed to heat and cool a building. Concrete has a high heat capacity, which means it slowly absorbs and stores heat energy, and likewise slowly releases it when the temperature differential shifts. This helps reduce the magnitude of the heating and cooling peaks, as well as shift the peaks to the times when utility rates are less expensive. This also translates to less energy needed to maintain a comfortable and more uniform indoor temperature. Precast concrete sandwich wall panels combine thermal mass with a layer of continuous edge-to-edge insulation. This eliminates thermal bridging or cold spots and can be verified using thermal imaging techniques. Since energy efficiency is one of the greatest factors contributing to total life cycle costs and environmental impact, this is a vital area to optimize. Precast concrete sandwich wall panels can greatly contribute to optimization of a building's envelope and often help reduce the total energy consumption of a building by as much as 30%. Precast concrete can have over a 100-year service life. It does not rot, rust, or degrade in the presence of moisture or when exposed to sunlight. Precast structures typically have fewer joints and do not require painting. All of these attributes contribute to reducing maintenance costs. High-performance systems must also be durable and able to resist natural and man-made forces. Essentially, resiliency expands on durability to include a structure's ability to be restored to its full function with minimal effort and resources after a major event, such as an earthquake or hurricane. This also helps minimize negative effects to the environment after such an event, since resilient structures do not need to be completely rebuilt. PCI has conducted extensive research on seismic design and the performance of precast concrete structures in earthquakes. This research has resulted in innovative design methodologies including precast seismic structural systems, or PRESS for short. These systems are designed to withstand high seismic forces and allow a building to self-right itself after a seismic event. Several of these concepts have been adopted into building codes such as ACI 318, which is referenced by the International Building Code. These systems now are used by developers across the country, including high seismic zones such as California. Precast concrete also offers protection from high winds and flying debris. Impact studies highlight the protection that precast concrete construction can provide. During this test, lengths of 2x4 projectiles were fired at 100 miles per hour towards various wall systems. The projectile penetrates through the 2x4 stud and cavity wall systems with 3/4-inch OSB sheeting. The first system was finished with vinyl siding, the second with 4-inch brick veneer. However, the 2x4 projectile is turned into toothpicks when it impacts the precast concrete sandwich wall panel system. Recent tests conducted by the Air Force Research Laboratory demonstrate the capabilities of precast concrete to withstand blast forces. The research examined the blast resistance of insulated precast concrete sandwich wall panel construction under full-scale blast conditions in a multi-story structure. These results help designers utilize precast concrete to protect against threats often required in the design of structures. Results also show that due to the inherent strength and resiliency of precast, the required standoff distance can be reduced when using precast concrete compared to traditional design requirements. By designing and building with high-performance precast concrete, we help ensure that people and items inside remain safe. Precast concrete also provides great protection against fire. Concrete does not combust and provides passive fire protection, which saves lives. Precast concrete also can easily achieve the required fire ratings by the building code. Precast concrete is an inert material and does not contribute to poor indoor air quality. Furthermore, since precast concrete can be erected so quickly, buildings are enclosed faster, providing a barrier between outside contaminants and moisture, while shaving months off your project schedule. In many cases, precast concrete can be left exposed on the interior of a building, eliminating the need for drywall, reducing waste, and increasing the overall durability of the interior finish. Precast concrete also does not provide a food source for mold, thereby helping to improve indoor air quality. Precast concrete is a high-performance material that integrates easily with other systems and inherently provides the versatility, efficiency, and resiliency needed to meet the multi-hazard requirements and long-term demands of high-performance structures. We invite you to discover high-performance precast today.